noise. Here we go. All right. So we've got we have. I got to think now. I think there was 25 people that didn't turn in the 4 homework problems from last week. You had 1 problem a day. Almost half of you didn't do it. But I'm over that. Okay? Because then I'm like, oh, I'll do the formative assessment. 25 people didn't do the formative assessment. But I'm over that. Okay? Because it's a new week. So let's go on to graphing this without a calculator. This is a review of what we talked about towards the end of last week. So let's, we should also have out our alternative sheet, our note sheet too. Remember that second page of notes that I was telling you that you should make? We should have that out too, because that's our plan. And that's going to be our plan for every single one of these problems going forward. So we should also have that out in front of us so that we can always refer back to it. Okay? Onliners, jump in whenever you feel like you think you know an answer. Okay? And yeah, we'll go for it. So step number 1 on our plan is what? Oh, my Atlanta. That's not our plan. What's step number 1 on our sheet?
The domain, any vertical asymptotes.
Domain and vertical asymptotes. And how am I going to find the domain and any vertical asymptotes? Set what equal to 0? Set the domain equal to 0 to get the domain? Or something else? Help them out. It's not domain. It's a D word, I'll give you that. But it's not domain. What do we set equal to 0 and solve? To find the domain. The denominator. Good job. Okay? So we set the denominator equal to 0, and we solve it. So we got 2x minus 3 is our denominator. We set it equal to 0. Solve it. I'm going to add 3. And I'm going to divide by 2. Okay? So I get x equals 3/2. So what would be my domain then? The domain of this rational function be?
Be all real numbers, but it can't equal to 2.
Love it. So all real numbers, but x cannot be 3/2. What is the vertical asymptote then, because I have restrictions? Vertical asymptotes. Anyone?
X equals
3/2.
Hold on. Combine those two. Krista, what were you saying?
I said the denominator before.
Oh, okay. Brady, I like the cone for a hat now.
Yes, sir. You gotta know it. It keeps me alert. That way my eyes stay attent.
Gotcha. He's, for those of you that can't see, he's got a cone on his, literally like a traffic cone on his head now. Okay? I heard somebody say it in the, from the onliners. It should be x equals 3/2 there. Okay? One thing I saw when I was correcting homework from last week is that people were just putting 3/2 there. Okay? And 3/2 is just a number. It's not a line. Okay? Vertical asymptotes are lines, so we have to give them in line form. X equals 3/2 there. Okay? How does that go onto my graph? Or how do I draw it on my graph? How would I draw a vertical asymptote on my graph?
That's a dotted line.
As a dashed line, yep, and it's going to be vertical, so it's going to be up and down, correct? So 3/2 is 1.5. So we're going to go through right there. Okay? And it's going to be dashed on your graph. Okay? That's step number 1. Now we're on to step number 2. What is step number 2? Step 2, anyone?
Horizontal asymptote.
How do I find the horizontal asymptotes? Go ahead, Brady. Or were you just waving?
I was trying not to inhale too much smoke. I just lit incense in my face, and I just went all up my nose.
How do I find the horizontal asymptotes from last week, Wednesday?
Using the degrees of the two equations, or the range and domain, not the range. Numerator and denominator.
Okay, and refresh my memory, somebody, if I'm going to compare the degrees, and that's correct, I'm going to compare the degrees at the top to the degrees of the bottom, numerator to denominator. Okay, what is a degree? If we're comparing them, we should know what they are. We've been talking about them for 2 months. What is the degree of a polynomial? We also wrote it down last week, Wednesday, so it will be in your notes. What is the degree of a polynomial?
The power of the lead coefficient.
Power of the exponent, Gabe? Is that what you're talking?
Yeah.
The exponent on the lead coefficient, or the exponent on a variable?
The variable.
On the variable. Okay. Can we throw in one more word to make it a universal definition? I like exponent on variable, but we need one word in front of all of that. And there's a couple of options that we have out there. Degree. What's the degree of a polynomial? The biggest exponent. Yeah, okay. So what's the exponent on the top of, or in the numerator on this function? Biggest exponent on 5x. Or the only exponent. 1? Everybody agrees with 1, so it's 1. Love it. Biggest exponent on the bottom. What is it? 1. Yeah. So that's a same case, because they're both 1s. So when it's the same, if its top is bigger, there's none. There's no horizontal asymptote. If the bottom is bigger, the horizontal asymptote is y equals 0. But if it's the same, then what? If they're the same, like we have in this case, what's the horizontal asymptote? Again, from your notes on Wednesday. Yes, any number over itself is equal to 1, but no in terms of this case, because it's not 1. Okay? So what's the horizontal asymptote here?
Is it 5/2?
That's 5/2 is a number, Brady, but if we set it in maybe line
A
form,
would be, right?
it's A over B, yep.
And then
Not X equals, Y equals horizontal.
Y.
Yep.
Oh, okay.
You know what I mean?
Slightly.
Okay? Because it's a line, Brady.
Yeah.
So it's got to be in line form. Watch out for your cone, man.
Will do.
Okay? That also goes on our graph as a dashed line, but now it's a horizontal line. So 5/2 is 2.5. So there. Okay. Step number 3 on our planned out work. Find the y-intercept. How am I going to find the y-intercept? I plug in 0 into my function. Yep, so I find basically f of 0. So that's going to be 5 times 0 all over 2 times 0 minus 3. 5 times 0 is 0. 2 times 0 is 0. Minus 3 is negative 3. 0 divided by negative 3 is 0. So my y-intercept is a point 0, comma 0. I saw a lot on the homework of just giving me the number, the number 0 there for that y-intercept. Okay? But y-intercept is a point, so it needs to be in point form. Okay? And that's this point right here. Okay? Step number 4 on our list of things to do. How am I going to find the x-intercept? Set the numerator equal to 0. So the numerator is 5x. If I set that equal to 0, I get x equals 0, and I get an x-intercept of 0, comma 0, which is the origin. Agree so far? Okay. Step number 5, we don't have yet. Step number 6, we don't have yet. Step number 7. What's step number 7? Step number 7.
Step number 7 is, oh my gosh, sorry, at least 2 points in each zone. So
Find some points in the zones.
yeah, find the points.
Okay. So if I'm going to be over here, I'm probably going to try 1 because we always want to go with that the whole number closest to our vertical asymptote. So that would be 1. If I plug 1 into my function, 5 times 1 is 5. 2 times 1 is 2. Minus 3 is negative 1. 5 divided by negative 1 is negative 5. 1, 2, 3, 4, and 5. So I go through that point right there. Then, as long as we're over here, let's try negative 10. Negative 10 times 5 is negative 50. 2 times negative 10 is negative 20. Minus 3 is negative 23. 50 divided by negative 23 is a little bit less, or excuse me, negative 50 divided by negative 23 is a little bit less than 2.5. Actually like 2.3 something, I believe. 3, 4, or somewhere in that range. That gives me 3 points in that zone. Love it. Then we're going to come over here. And we're going to say, well, we got to try 2 because 2 is the next whole number. 5 times 2 is 10. 2 times 2 is 4. Minus 3 is 1. 10 divided by 1 is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then let's do 3 because it's the next one. 3 times 5 is 15. 2 times 3 is 6, minus 3 is 3, 15 divided by 3 is 5. 1, 2, 3, 4, 5. And as long as we're doing it, let's do 10. 5 times 10 is 50. 2 times 10 is 20. Minus 3 is 17. 50 divided by 17 is almost 3. It's like 2.9, actually. Because 51 divided by 3, excuse me, 51 divided by 17 is 3. Okay? That gives us enough points to draw in our line.
Game show host question mark. That you had the enthusiastic like wording. I think you should be game show host. Just
Game
saying.
show hosting?
Just saying. Like the way that you said, draw in that line. Like I don't know if you're being a teacher. Like you definitely exaggerated line enough that you could be a game show host. I'm just saying.
And you know what the best part of it is?
What?
It's not even a line.
Oh,
It's a curve.
But you said it with so much force that I have to believe that.
That you got to believe that it's a line. Yep, exactly.
Impossible.
Mind's blown. Good thing you're wearing that coat.
Yeah, I stay alert in this household.
Okay? And that's the graph of 5x divided by 2x minus 3. Now, if we were to ask, and in this question we didn't ask, but if I were to have asked what's the end and asymptotal behavior, we can get that right off of our graph very easily now. So like for instance on here, this would be as x approaches negative infinity, f of x approaches 2.5 from below. Write that out for you. As x approaches negative infinity, f of x approaches 5/2 from below. That's that one right there. Okay. As x approaches, what's that, 3/2? 3/2 from the right, f of x approaches positive infinity. There's that one up there. Okay? And so on and so forth. Now, I have seen some weird things on your homework for end and asymptotal behavior. Like this, one of them that I saw for this was negative goes to that. For that end behavior. So you tell me which one is clearer and which one is more informative and which one is more accurate. I'll let you decide. Okay? But there's only one right answer, and the black one is not right in this case. Okay? Just so you know. Because I have no idea what's going on there. Okay? Or I've also seen, I gotta think of this one. It was like negative, oops, come on. It was like negative infinity to 5/2. No idea what that means. Okay? Okay? So that's non-negotiable in terms of math, is that format. As x goes to something, the function goes to something. And you've got to fill in those two somethings. Okay? All right. So this is just a refresher for your sheet, just to make sure that you've got your sheet all set and ready to go, because we want to have that done, because this is now the 4th time that we've gone through this extra sheet of notes. So if you don't have it on your extra sheet, it is 100% on you by this point in time. So step 0, we're not quite there. We'll get there on Wednesday. We'll fill in step 0 on Wednesday. Step number 1, find any and all vertical asymptotes. We do that by finding the domain, and we set the denominator here equal to 0, and we solve. Okay? I would also put on your extra sheet the extras that we've talked about for all of those, because then, like I said, it's one-stop shopping. You go to your sheet, you got your sheet out while you're doing all of your work, and you just follow step 0, 1, 2, 3, 4, 5, 6, 7 when it's all said and done. Yeah? Step 2, find any horizontal asymptotes. We got to compare degrees. If we've got big over small, that's a none case. If we've got small over big, that's a y equals 0 case. And if we are the same, that's a y equals a over b case, which we just had. Okay. Love it. Step number 3, find any y-intercepts. Okay, and that is we plug in 0. And that's going to give us 0, comma, some number. Step number 4, oops, come on now. Find any x-intercepts. Here we set the numerator equal to 0. And then that's going to give us the point, some number of 0. Okay. Step 5 we'll get to on Wednesday. It goes with step 0. Step 6 we'll get to next week. Slant asymptotes. Step 7, find any additional points to complete the graph. Okay? And like we said before, we want at least 2 points in each zone. Okay, what we want. All right? So, what I would like you to do now is I would like you to graph me f of x equals 3 over x minus 2. Okay? I want each and every one of you to graph that. Then I want you to state me the asymptotal and the end behaviors for that graph. Okay? In-personers, I'm going to come around and I'm going to look at your work. Okay? I'm going to look at everybody's before I do it. Onliners, when you're done, I'd like you to hold up your work to the camera so that I can see it. Okay? And then I want to check it that way too. Okay? Okay? Go for it. So, step number 1 says find the domain. Well, so the domain, we take our denominator, set it equal to 0, solve it, gets me x equals 2. So that tells me that my domain is all real numbers, but x cannot be 2, which tells me that I've got a vertical asymptote at x equals 2. So I go over here, and I say, first off, I say, let's make this graph just a little smaller. There we go. Now it's all on one page. So then I go, and I say, I've got a vertical asymptote, and it's going to be at 2. Okay. Then my horizontal asymptote, degree on the top is 0. Degree on the bottom is 1. So that is a small over big case. So my horizontal asymptote is y equals 0. Now, one thing that I should tell you is when you've got x equals 0 as a vertical asymptote or y equals 0 as a horizontal asymptote, and you're not using a second color, if you want to make dashed lines like this, to signify that your dash line, and you can actually see it, as opposed to not. Oh. Yeah. That's another good way to make asymptotes. Okay, love it. Next one, y-intercept. I got to plug in 0. So we got 3 on the top. We got 0 minus 2 on the bottom. That's going to be 3 over negative 2. So my y-intercept is going to be the point 0, comma, negative 3/2. So that's negative 1.5. Boom, shakalaka. Okay. X-intercept is next. I set the numerator equal to 0. Can 3 be equal to 0? No. So not possible. So that means I don't have an x-intercept. Okay. So there is no x-intercept, so I'm not going to cross the x-intercept or the x-axis. So then we go on to step 7. So let's go with 1 here. If I plug 1 in, that's going to be 3 on the top, and 1 minus 2 is negative 1 on the bottom. That's going to be negative 3. Negative 10 is going to be 3 on the top, and negative 12 on the bottom, because 10 minus 2, or negative 10 minus 2 is negative 12. That's going to be negative 1/4 right there. Then we can come over here. Let's go with 3 first. 3 over 1 is 3. 2 is 3. Oops, I can't do 2. Sorry, tap the brakes. Can't do 2. That's my vertical asymptote. I was meant to do 4. 4 is 3 over 2, which would be 1.5. And 10 is 3 over 8. That allows me then to draw in there and draw in there. Okay. Then it's asking me about my end and asymptotal behavior. Why are we jumping so much? Okay. So my end behavior would be as x approaches positive infinity, my function is approaching 0 from above. As x is approaching negative infinity, my function is approaching 0 from below. My asymptotal behavior, as x is approaching 2 from the left, my function is approaching negative infinity. And as x is approaching 2 from the right, my function is approaching positive infinity. Okay? Questions, comments, concerns, clarifications on any and all of those? Okay. With that being said, you can now do number 1 on this week's worksheet. Those of you in-personers, it's actually sheet number 2. It's page 2. Page number 1 was last week's worksheet. Okay. I put them all in together so that then that way if you have it, you got it. Okay? That's all I got for you. Thanks for playing along. We'll see you later. If you've got stuff to turn into me, Remember that it is progress report time, and so my progress reports are due by tomorrow. If you don't want the comment of has missing work, make sure all your missing work is turned in. Thanks for playing along. Have a great